Alright, so my first, I guess my first clip, reel, video, whatever of this series, I'm going to be using a couple of Arduinos and communicate wirelessly between them to actuate, a bunch of functions for this project. So these are the two wireless modules I'm going to be using. During the prototype process, I wanted to mount these to the breadboard, but if you mount them as is, you're going to short the pins and break the board. So basically what I had to do was solder this kind of a jumper, go in between these two bridges, and then give you the function to just plug it straight to your Arduinos. Soldering job wasn't too good, so they don't stick down like 100%. Like they'll stick, and then after a while they'll just kind of pop up. So that's why I'm gonna use the glue gun to hold them down, so that during the prototyping it won't just pop off. Okay, so scratch that. I tried to hot glue it down, and I thought it would be a bad idea because then I might accidentally, with like the microplastic, I might accidentally block these pins. I'm being very vague because I want this series to be basically two Arduinos talking wirelessly, and then they do things, and hopefully it'll be pretty cool towards the end. Okay, so jump cut. I did a lot of work since the last cut. So I went ahead and added a power switch for the power. Basically split this breadboard in half. So this side is going to be for this Arduino, and this side is going to be for that Arduino. So they're basically mirrored. I added a little toggle switch. I'm using a 7.4 LiPo battery. Just for this test bench. The top rails right here, so I basically labeled the power. So top rails is 7.4. That will feed whatever it needs to feed, like pull it down. I'm pulling the 7.4 into this buck converter, and then this buck converter steps it down to 3.3, and that's going to be for this rail right here, and that's going to be connected to this, which these mounts onto. What I'm going to do is use this top one as 3.3, and that'll power this, and then use this bottom line for 5 volts, and it'll power LEDs, buttons, etc. Because you don't want to mix power, and you don't want to use power greater than what your device is rated for. So yeah, let's just see how it works. So you basically, so now that powers both the Arduino, because I'm plugging straight from 7.4 volts into the Arduino via the VN. This buck converter, like I said, is pulling 7.4 volts, and it's stepping it down to 3.3 to be, safe for this. So this is basically mirrored. There you go. 2 separate powers. Next up is to wire this onto the Arduinos, and then write some magic code, and then have them talk back and forth to each other. Okay, so this is a jump cut to several days later. Basically, I had to do a lot of troubleshooting for the wireless modules. I've done this before, and I just forgot what I did with the previous project, but I added a button and a light switch because I wanted to test that the wireless communication works. So basically, nothing is hooked up. These two Arduinos are independent of each other, right? They have their own power supply and power management routing. But there's no way they are connected to each other. So if I press this button to the left, the LED to the right will light on, and vice versa. So here we go. And test that this works. The thing that you got to be aware of are the addresses. So you got to specify, you got to remember that the addresses are flipped in terms of their reading and writing pipes. And the thing that took me so long, it took me a couple days to figure out, was the data rate. I had this set to the lowest data rate, and it was like causing intermittent communications. That was no good because it wasn't consistent. I was able to do this, but to do this kind of communication from the Uno to the Nano, it wasn't lighting on like it's doing it now. But now that we got this going, I'm going to test the other wireless modules that I got in the pack to make sure they're all good. But this is basically a success. So stay tuned for the next update.